In this lesson, we're going to learn about zero and negative exponents. Example 1, how do negative exponents represent repeated division? Well, first of all, let's start with the exponents that we know. We have evaluated the positive exponent, so starting with 2 to the first power, we know that that is just 2. And 2 to the second power is like taking 2 times 2, and so we'll have 4. 2 to the third power is 2 times 2 times 2, so then we'll have 8. And 2 to the fourth power is equal to 16. All right, so now notice, as we are getting bigger, as we go from here to here, I'm multiplying each of these. You'll notice that to go from 2 to 4, we multiplied by 2. To go from 4 to 8, we multiplied by 2. And 8 to 16, we had multiplied by 2. So every time you add on an exponent, it's like you're multiplying by another 2. Now, if we were to back up then on this chart, if we went from 16 to 8 and we were to go now this way, notice how we are dividing by 2. To go from 16 to 8, we would have divided by 2. To go from 8 until 4, we would have divided by 2 and divide by 2. All right, so now let's start then with the 2. And we have 2 divided by 2 is equal to 1. And we're going to talk about how anything to the 0 power is equal to 1, and I'll explain that more in just a little bit. So again, we're going to then divide by 2 and continue, and as you divide 1 by 2, you get 1/2. And as you divide that by 2 again, you get 1/4. And divide by 2 again, you would then have 1/8, and divide by 2 again, we would have then 1/16. So notice, when I had 2 to the first power, I had 2, but when I had 2 to the negative 1 power, I had 1 all over 2. It's like I have the reciprocal of it. When I have 2 squared, I have 4, but when I have 2 to the negative 2 power, I have 1 all over 4, and so forth. So that brings us to the negative exponent property. The negative exponent property states that if you have a to the negative n, that is equal to 1 all over a to the positive n. Same thing, if you have 5 to the negative 3 power, that is equal to 1 all over 5 to the third power, which then can be equal to, you can simplify it further and have 1 all over 125. So basically what we're doing is, to make it a positive exponent, you are taking the reciprocal, or you're flipping it, or you could say you're bringing it down, and you'd have 1 all over 5 to the third power, positive 3 power. Example 2, how do I evaluate negative exponents? And so there we have our negative exponent property above. The first method, we are just going to simply show this out the long way and showing you what happens as we then have these negative exponents. If I have x to the third, that means I have 3 x's that are multiplying each other. And if I have divided by x to the fifth, that means I have 5 x's on the bottom. And now we know that any number divided by itself, it cancels out, it equals to 1. The same thing, x divided by x becomes 1. X divided by x again would become 1. And x divided by x becomes 1. Now, because this is on the top where they've all canceled out, you do need to put a 1 on the top as a placeholder. And then, so what you have left then is you have 1 all over x squared, because 3 of those x's had canceled out. Now, if we were then to use the quotient of powers property, remember the quotient of powers property says when you're dividing exponents with the same base that we're subtracting the exponents. So if I have x to the third divided by x to the fifth, we're simply going to subtract the 5. So 3 minus 5 gives us x to the negative 2 power. And now we just talked about how that negative exponent property says then that to make this negative exponent positive, we are going to flip it, or I like to think about it as if I bring it down below the
that division sign or the division bar there in the fraction, that it then makes it positive. So I flipped it and I have 1 on the top and I have the x squared on the bottom. And notice, you have the same answer for both of these.
All right, so let's go ahead and take a look at what we have here. So for number 1, we have x to the 5th divided by x to the 5th. Remember I mentioned that I was going to talk about how that 2 to the 0 power became 1. Well, x to the 5th divided by x to the 5th, what you have here is you've got these 5 x's. And then we've got another 5 on the bottom. And remember that all of these x's are canceling out. And essentially what you have is they've all canceled out, so you have 0 x's, and they all then result in 1. And so right here we have, if we were to apply that, the division property, we would subtract, and we have x to the 0 property. They've all canceled out, and because they all canceled out, they are just going to equal to 1. So anything to the 0 power is always going to equal to 1. So x to the 0 power equal to 1. 5 to the 0 power is equal to 1. All right, so let's take a look at question number 4. Now, the question number 4, it talks about these negative exponents then. And remember what we had said is that to make a negative exponent positive, we're going to do the reciprocal. We're simply going to then bring it down or do the reciprocal. I like to think about it as if that fraction bar, if you need to make a negative exponent positive, just bring it over the fraction bar and it is going to be a positive. But what we have to have at the top here is a x to the, we have to have a 1 on the top and x to the 3rd. So again, we're going to make this positive by bringing it down. So I'm going to have 1 on the top and 6 squared. Now it's okay if I leave it as 1 all over 6 squared, or I could evaluate the exponent and just have 1 all over 36. Either one is just fine. So now I'd like for you to pause the video and for you to try number 6 and then resume it when you're done.
And hopefully then the answer that you have here is 1 all over 2 to the 4th or 1 all over 16. All right, question number 7. So let's take a look. We have -6 in parentheses to the -2 power. Well, again, we're going to make this entire, or the exponent positive by taking the reciprocal. You'll have 1 all over -6 squared. Now, you do have to keep the parentheses on here, or you could evaluate that and say, well, we know that -6 squared when it's in parentheses is like -6 times -6, and you could have 1 all over 36. For question number 8, however, we have this negative on the outside. So we're going to start just like we did the previous one, and we're going to flip it, bringing 1 all over 6 squared. Well, whoops, I'm sorry, -6 squared. Remember, we have to follow the order of operations, and the order of operations would say, well, we need to evaluate that 6 squared first and have then 1 all over -36. So I know we're still struggling with that a little bit. Just remember that they're different if you've got the parentheses around them and if you don't have the parentheses. All right, so question number 9, we have -2 in parentheses to the 0 power. Well, anything to the 0 power is going to be equal to 1. This would be different, and I should have had one like this in the notes packet, but if you had -2 to the 0 power without the parentheses, in this case, you'd need to evaluate this part first, and you'd get the 1, and then since that negative is on the outside, you would then have a -1 there.
All right, question number 10. I have 2 times x to the -2 power. Now, this -2 is attached to the x. It's not attached to the 2. The 2 has actually an exponent, even though we don't have one there, it is a 2 to the 1st power. So remember, to make our negative exponents positive, we have to do the reciprocal, but we're only doing that to our negative exponents. And so that 2, we have to leave that alone on the top, And to make the x to the negative 2 positive, we're going to have x to the second power on the bottom. So I'm going to have then 2 all over x squared. So I'd like for you to pause the video. I'd like you to try number 11, and then let's resume it to see how you did.
All right, so hopefully the answer you have is 5 all over x to the 5th power. Now, question number 12, now we are going to be applying the quotient of the power property where we're dividing the exponents. And remember, dividing the exponents at the same base, we subtract the exponents. So x to the 3rd divided by x to the 4th, we're going to subtract the 4 and get x to the negative 1 power. Well, to make that positive, we know that we have to flip it, bring it down, and we have 1 all over x to the 1st power. All right, so let's pause the video again, and I'd like you to try number 13, and then you can resume. All right, question number 14. We have 4x to the 3rd divided by 3x to the 6th. So when we have this 4 and divided by 3, because you can't divide those evenly, we're just going to leave the 4 and the 3 alone. And so let's, though, focus on the x to the 3rd divided by x to the 6th. So because you've got the exponents at the same base, you're going to subtract them. So remember, we're keeping the 4 alone, and we're subtracting 3 minus 6. We have negative 3. And then the 3 is still on the bottom. Now, we don't want to have that negative exponent, so we're going to just simply bring that down. And you'll have 4 then and 3x to the 3rd on the bottom. And remember, don't touch that 4. That 4 is not attached to that x, and that does not have the negative exponent. So for time purposes, we're going to skip number 15. All right, question number 16. Let's evaluate these two parts separately. So 10 divided by 5 is equal to 2. Now, x to the 3rd divided by x to the 3rd, remember you subtract those exponents, and it actually gives you an x to the 0 power. And remember, anything to the 0 power becomes 1. Basically, what's happened here is all 3 of those x's have canceled out, and you are then left with just 2. All right, let's take a look at question number 17. Again, we're going to subtract our exponents. So let's start there. We'll take y to the 5th divided by y to the 3rd, subtract the exponents, and you have y squared. And when we take x to the 3rd divided by x to the 7th, we get x to the negative 4 power. Now, again, you don't want to leave that negative exponent. And so we're going to leave that y all alone, leave it there. However, you need to bring this down to make that a positive number. So y squared all over x to the 4th power. Because of the length of this lesson, we're going to skip number 18 to save on some time. All right, so question number 19. So it looks like we have now, we're multiplying these exponents together. And remember, when you multiply exponents at the same base, we add the exponents. So we're going to take x squared and then times x to the negative 5. Well, 2 plus negative 5 is negative 3. So to make this then a positive exponent, we need to then bring this down and have 1 all over x to the 3rd. All right, question number 20. Be careful. Don't take 4 times 4. You're taking 4 to the 5th times 4 to the negative 3rd, and you are adding the exponents. So 5 plus negative 3, you're going to be left then with 4 squared, and then you could evaluate that further and just say 16. Either one is just fine. Now for number 21, we are going to then multiply and have 14, and then we'll multiply these with the same base and have n, so 10 plus negative 3 is n to the 7th power. All right, so we're going to stop here at number 21. We will finish these up on another day. So in this lesson, we learned how to evaluate 0 and negative exponents.